Hello, we are team XAE-A12, and for our project, we did the sensor data project. And in order to do this project, we took data from the MATLAB mobile app, and then through App Designer, we sent it into App Designer, and we used App Designer and ThingSpeak to analyze the data and come up with a lot of cool and useful ways to look at the data. And for this part of the project, I mainly focused on the callbacks that were being created in App Designer, and I did a lot of the coding for those. And I was also helpful towards other people in the team where help was needed.
Hello, my name is Huirache. And my part of the project was the reach component, mainly focusing on understanding ThingSpeak and creating a CBS file for the data, but I also too helped other teammates in case they needed help.
Hi, my name is Jordan Ramirez. My main part of this project is working mainly with the ThingSpeak and the Twitter functionality of it. So in the ThingSpeak, I created the linearized graphs and worked with the graphs and the histograms to get a better understanding of the data that is being taken in and calculating the tweets that are necessary.
Hello, I'm Anthony, and I'm going to be discussing the code involved inside App Designer. But before we jump into it, I'd like to just go over a little flowchart that I made of like kind of how it works and like what the basic steps are. So in order to do this, you're going to have to first download the MATLAB mobile app, and then you're going to collect data through the MATLAB mobile app, and then you're going to download the data from the MATLAB drive, very similar to a Google Drive, and then you're going to run App Designer. You're going to upload the data into the app by clicking the Load Data button, and then you are going to click the buttons or labels inside the apps, and you're going to watch the magic unfold. All right, now we're going to move into how the magic actually happens, alluding to the simplified flow chart that I showed earlier. So for starters, you're going to find your properties, pretty standard stuff. Then we're going to move into the load data button, and basically all you do here is you're getting an MIT file or an MAT file from anywhere in the computer. We use the synchronize function to combine those two timetables, the position and acceleration, into one timetable, and then you convert that timetable to a table, and then you store it within the App Designer table. Next, we're going to move into the Create CSV File button. So we basically take the data that we loaded in, and using write table, we take that data and under whatever file name that is chosen by the user, it is saved as a CSV file. And then next, so this just kind of updates the table where your data is being stored in the app. And then for the import map, I mean, nothing too crazy here, just using what we had done in the previous lab, expanding on it a little bit, playing around with the X and Y limits, making it so that the same image can be used to show multiple routes within that sized image. And then we're going to go into a few plot functions here. So we plot the path. When Luis shows the app working and how it functions, comment is a pretty cool feature and it's very visually appealing. And then you got your plot speed, your plot altitude, your plot acceleration, and for the acceleration, since you have the X acceleration, Y acceleration, and Z acceleration, we decided to do so that you can plot each one individually. So you can plot the X, plot the Y, plot the Z, or if you would so please, you can plot them all at once. And then a little feature that we added, just to make our app more interactive and be able to show the data better, is this find peaks command, and basically just opens up a new window within the app, and it puts triangles at where the peaks in the data are, so it helps to show local maximums. And you got your speed peaks, altitude peaks, X acceleration peaks, Y acceleration peaks, and Z acceleration peaks. And that's all I have to cover. I'm going to hand it over to Luis, and he's going to show how everything works together and functions. and how it all visually comes together.
Hello, my name is Huirache and I will be teaching you about the functionality of our app and how to use it, but please do like and subscribe. First thing you do is download our app, of course, and then you open it through your files like so. Once you open it, you should be sent to App Designer, and you should be in Design View, like so. In Design View, you can move around the buttons, change the font and the headings, but we don't want to do that. What we want to do is run this app. When we run this app, we'll be giving this screen, and in this screen we could interact with the buttons and see the data in the graphs. Of course, we have to have data, because if we don't have data, then you'll get this error where no data has been loaded. So we have two types of data, car and bike data, but I will be showing you the car data. So once you uploaded the car data, you'll be giving this, the time you took, the latitude, longitude, altitude, the speed, x, y, and z. All this data can be plotted here by the click of these buttons, such as. Another cool thing about our app is that you can see the peaks of every single peak on the graph. And x, y, and z, you can see the peaks directly here. Or you can see all of them by plotting all. Another cool thing about our app is that you can import a map where the data was taken, like so. And you can plot a path around where the data was collected. As you can see, this line here is where all the data was collected with in the car, and the blue circle should be the car. It should be doing a loop around the neighborhood. Another cool thing about our app is that you can create a CVS file, which is basically an Excel file, read, and you can save it, and you can pull up the data in an Excel form. Now you could also send all this data to ThingSpeak, but that's not my specialty. That specialty is up to my good friend Jordan.
Hello. Now we'll be taking a look at the ThingSpeak send data to ThingSpeak function. As we look at the callbacks, we can see that we are sending in the raw data from our table into its own ThingSpeak channel. But in addition to that, we are also calculating the average speed, the average altitude, the maximum speed, and the maximum altitude into a second channel as well. So when you click the Send Data to ThingSpeak button, it'll send all of that data to their own respective channels in their own respective fields. Now let's look at our app in action. First, let's load in our car data. And as you can see, it has been loaded in. Now let's send it over to ThingSpeak, where it'll send both of our data to the channels and also send Twitter notifications. As you can see, we have created two channels here. The drive data was where the raw data will be sent to, and analyze data is where our averages and maximums will be sent to. Looking at the drive data channel, you can see that the graphs look very similar to the graphs as shown back in the app, and we have also added these new visualizations to get a better understanding of what is happening to the data as it is being collected. In addition to this channel, we have also created the second channel called Analyze Data, where our averages and maximums have been sent to. This is useful for sending the data directly to the Twitter notifications. Looking at this page, you can see that we have multiple reacts for each value of the channel. These reacts can even determine which mode of transportation the data was taken on by having different reacts for the maximum speed. Let's take a look at the maximum speed for the car react. As you can see here, this react only occurs when new data is being inserted into the channel. It reads the data in the field relating to the maximum speed, and if this value is greater than 10 meters per second, then this entire react will activate it by sending this tweet. However, if the maximum speed is less than 10 meters per second, then this react will activate, which will send this tweet specifying that the data was taken on by a bike. As you can see, the Twitter was able to send in all of the correct data that was sent from the ThingSpeak app. So it correctly calculated the altitude, altitude, maximum speed, and average speed, and is correctly to determine that it must have been taken in a car rather than a bike. Well, that's it for our app for today. Thank you for watching.